Okay, this is number 10 from the complex numbers, and we're going to look at just how this comes together. So, let x and y be real numbers, and w be one of the complex solutions of the equation. Z cubed equals 1. Okay, so therefore we're dealing with roots of unity. However, we have this. X and y are real. That tells us that we don't have the trivial solution, which is z is 1, because then y wouldn't be real. Y, or, yeah. Okay, so here's what you want to evaluate. Now, I'm going to show you one method, and then I'll explain the method on the mark scheme. So the first method is by using the roots of unity, and since x and y are real with w not equal to 1, then we want to use this. Oh, lost my place. Cos 2 pi over 3 plus I sine 2 pi over 3. That's one of the other roots, or the third root, as we're moving around because they're equally spaced, as you know from the, is two of those, which is 4 pi over 3 plus I sine 4 pi over 3. Good. So this gives us, by the unit circle, minus 1/2 plus root 3 over 2i, because 2 pi over 3 is special pi over 3, which has cosine minus 1/2. Again, this is all from the unit circle stuff. And sine reference angle pi over 3, second quadrant, positive here. Now 4 pi over 3, cosine is again going to be minus 1/2. But now sine is in the third quadrant, so we're minus root 3 over 2i. Okay, both of these are now W2 and W3 if you like, because we're not going to deal with the W equal to 1. Alright, so when you evaluate them, you could use your calculator and just put this in, and then as W and W squared, and you'll find out that it becomes 0 when you work it out. And this one also gives you 0. So I won't put that into the calculator, I'll leave that to you, but once you do, I assure you, you get 0 here. Okay, so this is one of the methods. Now the mark scheme does things a little bit different. They say, well, we have this thing, and we are not dealing with w equal to 1, but we're going to check if it divides into it, because we know that it is the trivial answer. 1 minus this. When you do the long division, you get no remainder, and you get w squared plus w plus 1. Okay, that tells you that this is a factor, so by the factor theorem we know then that that has to equal 0. So two different ways to think about it. That doesn't jump out at you so obviously. Okay, then we go to part B, which once you do the expanding of the algebra you see is not so bad. W cubed x squared plus w squared xy plus, let's see, we did that, w4 xy, and last we get w cubed y squared. Okay, well, we know here that w cubed is 1, so therefore you have x squared, and then w squared xy, and by the way that we're dealing with cube roots of unity, so the fourth power is the same as the first power, okay, because they're equally spaced, and so round and round we go. And again, w cubed is 1, so we have that. So now you have x squared plus y squared plus, oops, xy factors out w squared plus w. So w. Okay, so this tells us something. Again, we're using that thing there. So you can solve this for w squared plus w and you get minus 1. So this part is going to be minus 1 because of this. Okay, so that leaves us with x squared plus y squared minus xy.